Hello everyone. So this is the real time actually from the previous video. Okay, so I made this large language model. Okay, the model will be trained with about 2 million characters. Okay, so I'm not using transformers model. I just only use the sequential neural net. For more precise, I'm using the ELSM model. Okay, so this is more easier than the transformers. Okay, so probably after this I will convert it into the transformers model. Okay, so but this time I will not going to deep dive into the every single line of codes, because a lot of things here. Well, probably on the next video we will grab on every single line of this code. Okay, so today I just want to show you that the programs are running very well. Okay, so I'm using C++. See that? Okay, I'm using a CMake tool to compile all these kind of programs. Okay, so instead of using GCC, I'm using the NVCC. Here, as you can see, this command. Okay, so I listed all the tasks on every single compiling, so I can see what kind of the tasks that they've been running with the CMake. Okay, so here the GCC, I'm using GCC 9. Okay, so the CUDA is 11.4. Okay, blah blah blah. Here found CUDA 11.4. so this is the one of the evidence that the program are compiled into the GPU kernel instead of the CPU. Okay, so here are the library from CUDNN. Remember that I copied all the CUDNN files into the library 64 and the include as well. So the compilers took this library from CUDA neural network. Okay, so this is all the file, and also the file here from the lib64. Okay, so it is also coming from the CUDA neural network. You say library NVIDIA real-time compiler. Okay, so this is the CUDA compatibility, which is 6.1, belong to P400. Okay, blah blah blah. Torch library, this is actually only the libtorch directories here. So don't make a mistake when we do the list of the directory libtorch. Okay, so this is the CUDA architecture, which is the CUDA compatibility. Okay, so this is the C++ files. Okay, that's it. But actually this flag is coming from the CMake. Actually, you just ignore it. However, you can see that it's only filled with the CUDA lib directory and blah blah blah. Okay, so as you can see here, this is very clear. It is clean, no warnings and no error. Means that the compiler was successful. Okay, then I generate the binary file to run the execution files. So it is also successful. Then I run the source binary file. Yeah. Okay, it says CUDA device 1. Okay, so the model trainings on GPU with the actually memory uses only 166 bytes. It is very small. Okay, so it is also generating the vocabulary text. Yeah. So later on, if we retrain the model, actually this is also available for retraining the model. Okay, but to do that, we need also to give the model the vocabulary as well. Yeah, otherwise it doesn't know the reference of the text vocabulary text. Yeah. Okay. Here that the encoding index is about 2 million, yeah, with the vocabulary size of 77. Okay, so the model trains in every single batch. Well, the totals of the batches is about 3,000, yeah, something. Okay, now this is the number of trainings epoch. Yeah. So the loss function starting from 2.4. Okay, so every single training it must pass about 3,000 batch. 2.4 it down into 1.2. Averaging is training loss about 1.6, yeah, from 2.4. Well, this is indicating that the models are running good train. Yeah. Okay, so it is also reducing the loss functions, which is very good. Okay, yeah, well, I think that's it. Yeah, we just need to wait until all the training process accomplished, then I will come to you later. Okay, thank you guys. Okay, now we check the load of the GPU. Yeah. Okay, so before we look up over here, so we just need to see the GPU process of the execution file. Yeah, here. So it takes about half of the maximum capacity RAM of the RAM. Yeah, means that it is safe. Yeah. Hopefully the systems will not hold on or hang or something. Yeah. Okay, so the GPU fans quite running faster. Yes, about 44% because it is on load. It took only about 1.2 gigabyte. Yeah, I think it's half of the capacity. Here, from here, this and this. It's almost quite the same. Yeah. Okay. It is telling the CUDA version 11.4. Yeah, as I mentioned before. Yeah, from the previous video. So this another GPU of GTX 760 is not available. Yeah, for the GPU. Okay, so the GPU fans only cooling the monitor display only. Okay guys, so from this information telling that the NVIDIA Quadro P400 are available to run about 2 million tokenized level parameter. Yeah. Okay, well, actually later on I will show you the model also been trained with 4 million character level tokenizer, which is bigger than this one. Yeah, and it is also capable. The only thing is only it took longer times than this. Okay, but the loadings here over here it is almost 2 gigabytes. Yeah, I think how much hyperparameter that been taken with this model. Okay guys, I think that's it. If you have any questions, you may put on the comments below. Okay, thanks for watching. Okay, now the training has already done with 30 epochs. Here you can see the loss functions only takes about 0.9. It is very good, so the model has learned very well. Okay, so as you can see here that the model already saved into this kind of files name. So later on, if we want to retrain the model, it is also available, but must include the vocabulary text. Otherwise, the model doesn't recognize the reference of the vocabulary characters. Okay, that's it. Now it is starting us to prompt what is the starting characters begins, and then here how many characters they would like to show, and here are the prediction. Okay, so as you can see here that the characters got very good composition. I mean it has very good coherent and homogeneous. Seems it is the sequence is good because there is nothing missing, or there is no strange characters appear. So it means the model really got very well training. So as you can see now we got the more difficult. It is starting from characters number 700, and it will show the 3000s after 700. So means this S is appear from the characters 701. Okay, and then this is going through until the end of the 3000s character here. Okay, so as you can see here that the model is very good. I mean, as you can see here, there is nothing happen, or there is no wrong characters composition. It is very coherent. Okay, and also homogeneous. Okay guys, so I just only trained this quite mid-up character level tokenizers model, which has 2 million characters and running on the GPU P400, and it is successful. Okay guys, well, probably later on we will discuss about the every single lines of code here, but unfortunately I just only use the C++ here guys. Sorry for that, because as you might know that the C++ is very close to the machine language, so the compilation will be very fast. Okay, so there is no masking, or there is no framework here. The only thing this only took for LibTorch framework, but LibTorch also made with C++, so the compilations runs quite very fast. Okay guys, probably that's it. Thanks for watching. See you the next video.